Hello friends, in this video we shall discuss with respect to the previous year question paper of UGC NET Electronic Science paper, which was conducted by National Testing Agency on 7th January 2026. In this part 1 video we shall discuss from question number 1 to question number 25. In the next parts of the video we shall discuss from question number 26 to question number 100. Look at your friends, see the previous year cutoff. It is not more than 64%. You can see the cutoff of JRF and assistant professor based on the category. You will be getting a fair idea. Hello friends, this is Arun Kumar here. I welcome you to my channel Craving Gyan. If you're visiting first time to my channel, make sure you're going to subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. Let us move on to the first question. This question is from VLSI MOSFETs. What is the question is, what is the voltage at the output node of the given circuit? Assume VDD equals to 1.8 volts and the threshold voltage they have denoted by Vn, which is equals to 0.4 volts, and the body bias effect is negligible, nothing but no need to consider the body effect. So what is the value of VDD they have specified is 1.8 volts. That is fed at gate terminal of NMOS transistor, and here VDD potential you're going to give 1.8 volt. Now look at the things. What is the threshold they have specified? It is a 0.4 volts. Now since this is a NMOS transistor, we have fixed gate terminal. Now you have to fix drain and source terminal. We know that the drain will be at a higher potential when compared to source. So left side will be the drain terminal and the right side will be the source terminal. Now look at the things. We know that the NMOS is capable of allowing a strong logic 0, but it fails to allow strong logic 1, nothing but it allows weak logic high. Similarly, in the case of PMOS, it allows strong logic 1, but it allows weak logic 0. So 1.8 volts if you are feeding at the input, given the VDD at the gate, we know that in order to turn on the NMOS transistor, what is the condition we will be having is VGS should be greater than or equals to VTH. So this node, how much it can take means 1.4 volts. Maximum potential how much it can take means 1.4 volts, nothing but VDD minus the threshold drop you're going to get. Say suppose whether if it charges to 1.41 volts or not. The moment if I am assuming 1.41, VGS 1.8 minus 1.41, how much? 0.39, which will be less than the threshold voltage. The device will be in the off state. So greater than 1.4, not possible. Now look at the things. For the M2 transistor, this will be the gate terminal. At the gate, what is the potential you are feeding? It is not VDD. It is 1.4 volts we are going to feed. Even this MOSFET is also having the same threshold voltage, that is a 0.4 volts we need to consider. What is the value of VDD you are going to get? 1.8 volts. Now for this MOSFETs to turn on, what is the condition means VGS should be greater than or equals to VTH. So the left side potential will be the drain terminal and right side will be the source terminal, because drain will be always taking the highest voltage or highest potential. Now look at the things. VGS greater than or equals to VTH, what is the value you are going to get? 1.4 minus 0.4, maximum you are going to get 1 volt. The moment if you are treating 1.01, it is achieving VGS greater than VTH, he is going to fail. So for this first question, the corresponding option that is going to follow is option 3 is correct, nothing but the output voltage will be equals to 1 volt. Second question what they have given is, we have to arrange the formulas of beta in the order with respect to the medium they have specified. When I was explaining you the EMTL lectures, I have specified that the formula associated with this is very important. The values of alpha and the values of beta is very important. We know that in the case of lossy dielectric, what is the value of beta you are going to get? This is the value of beta, nothing but omega into under root of mu sigma divided by 2 into root of 1 plus sigma divided by omega epsilon the whole square plus 1 you're going to get. This is the value of beta what you're going to have. Now, in the case of free space, what is the value of beta you're going to get? In the case of free space, what is the value of beta? Beta will be equals to omega divided by c. In this, what is the value of mu r? Mu r equals to 1. What is the value of epsilon r? Epsilon r value is also equals to 1. In the case of good conductor, what is the value of beta you are going to have? The value of beta will be equals to under root of omega mu sigma divided by 2. This is equals to alpha. Now, in the case of good conductor, we know that we will be having one concept called as skin depth. Skin depth, how you are going to denote? You are going to denote by delta. What is the value of delta? 1 divided by alpha or 1 divided by beta. In the case of lossless dielectric, what is the value of beta you are going to have? What is the value of beta you are going to have? Beta equals to omega into under root of mu epsilon. You can also rewrite this one as omega into mu. I can write it as mu naught times of mu r, and epsilon I am going to take it as epsilon naught times of epsilon r. We know that 1 divided by under root of mu naught times of epsilon is what? C. So I can rewrite it as omega divided by c into under root of mu r times of epsilon r. If they are giving this kind of options, you should be in a position to deduce the equation. So based on all this matching, the corresponding option that is going to follow is option 3 is correct. In third question, what they are given is, this question is based on assertion and reasoning, and this is a part of power electronics subject. A chopper is a one which is going to convert a fixed DC input voltage to a controllable DC output voltage, and the chopper circuit require forced or load commutation to turn off the hysteresis. This assertion is true. And the reason what they have specified is the chopper circuits are dependent upon the type of commutation, true, and also on the direction of the power flow. Yes, so reason is giving the proper explanation for assertion, so I can go for option 1. So for this third question, corresponding option that's going to follow is option 1 is correct. In the fourth question, what they have specified is, this question is from a 2-port network. So what they are telling us to find the Z parameter equivalent, Y parameter equivalent, H parameter equivalent, as well as a T parameter equivalent or ABCD parameter. So what we can do is, like given the bulk network, let us try to reduce the network. Now look at the things. How can I reduce means, this entire thing is in a delta network. I'm going to convert into a star network. So what I'll be having 1 ohm over here, and 1 resistor I'll be taking, and 1 more resistor over here, and 1 resistor. That's it. Now look at here, friends. What is the value of this resistance? This resistance value is 3 multiplied by 3, which is 9 divided by, what is the total resistance value in the delta? 6 ohm, 3 ohm, 3 ohm, which is equals to 12. So 9 divided by 12, which is equals to 3 divided by 4, or 0.75 ohms. 0.75 ohms. Now what is the value of this resistance you are going to get? 3 multiplied by 6 will be 18. 18 divided by 12. 18 divided by 12 you are going to get, which is equals to 1.5 ohms. Similarly, this value is also equals to 3 multiplied by 6 divided by 12. So what you are going to get? 1.5 ohms. This is V1 and this is V2. Now these two resistant elements are in series. So can I add up? Yes, I can add up. 1 ohm plus 0.75 ohm will be 1.75, and here the resistance value will be 1.5 ohms, and here you will be having one more resistance. This value will be 1.5 ohms, and you will be having the potentials as V1 and V2. Now look at the things. Let us try to find out the Z parameters equivalent, right? So what you're going to have Z11, Z12, Z21 and Z22. How you are going to find the values of Z11? Z11 is nothing but in the first port you try to walk up. What and all the resistance elements you are going to encounter? 1.7 plus 1.5, which will be equals to 3.25. When you try to move from port 1 to port 2, what is the resistance you are going to face? 1.5. When you try to move from port 2 to port 1, what is the resistance you are going to get? 1.5. You try to travel in a port 2, what is the total resistance you are going to get? 1.5 plus 1.5, which will be equals to 3. So what is the value of Z11 you are going to get? 3.25. What is the value of Z12 and Z21? 1.5. What is the value of Z22? 3. So A is correct. Whether B is also correct? So dilemma lies in option 1 and option 2. Which two options you can eliminate? Option 3 and option 4 you can easily eliminate. Now what is the Y parameter equivalent? How we are going to find out? Y is given by Z inverse. How can you write Z inverse? 1 divided by det Z into adjoint of Z matrix. Adjoint of Z matrix. So first let us try to find what is the determinant Z. Determinant Z is given by 3.25 into 3 minus 1.5 into 1.5. So this will be 9.75 minus 2.25. What is the value of det Z you are going to get? 7.5 ohms you are going to get. 7.5 ohms you are going to get. So what is the Y parameter equivalent you are going to have? Y matrix is given by 1 divided by 7.5 into take an adjoint. So 3.25 and 3 is there, right? We have to interchange the position. 3 over here and 3.25 over here. For this diagonal, append the opposite sign. So this will be minus 1.5 and this will be minus 1.5. That's it. You will be getting the answer. What is the value of Y11 you are going to get? 3 divided by 7.5. What is the value of 3 divided by 7.5 you are going to get? 0.4. What is the unit? Mho. What is the value of Y12, which is minus 1.5 divided by 7.5? 15 ones, 15 fives. 1 divided by 5 is how much? Minus 0.2 you are going to get. 0.2 mho, which is same as what? Y21. Which is same as what? Y21. What is the value of Y22 you are going to get? Which will be equals to 3.25 divided by 7.5. What is the value? 0.433 mho you are going to have. 0.433 mho you are going to have. Y11 is correct, Y12 is wrong, Y21 is correct, Y22 is wrong. Looking at the network only, directly you will be in a position to answer whether the Y matrix is correct or not. Because Y12 equals to 0.5, Y21 equals to minus 0.2. Here all the elements are passive elements. So you will be getting, and moreover the network will be the symmetrical one as well as, like, it may be reciprocal or the network is reciprocal but may be symmetrical or may not be symmetrical. So since the network is reciprocal, always you should have Y12 which is equals to Y21. I repeat, Y12 should be equals to Y21. Here it is not there, so directly you can eliminate this option B. So for this, the corresponding option that's going to follow is option 1 is correct. In the fifth question, what they have specified is, on the list 1 they have given the addressing mode, on the list 2 they have given some instructions. Immediate addressing mode will be move dptr, 4521h. Immediate value you are copying to dptr, right, external pointer. And in the case of indexed addressing mode, it will be move c a, at the rate of a plus dptr. And in the case of register addressing mode, we know that we will be having 8 registers varying from R0 to R7. So it is move a, R0. And in the case of register indirect addressing mode, it will be move a comma at the rate of r0. So when you try to solve, what is the option you are going to get means for the fifth question, option 2 is going to follow. For question number 6, how we can solve is, we are very much familiar with respect to CMOS topics as well as BJT topics. In the case of CMOS technology, it is going to offer low static power dissipation. What is the static power dissipation in the case of CMOS? Ideally, it is 0. Practically, it will be very low value. So, in the case of CMOS, the static power dissipation will be low. Whereas in the case of BJT or the IC technology, you will be having high static power dissipation. So for C it will be 1 and for D it will be 2. So the corresponding option that is going to follow is option 2 is correct. In the next exam, if they are asking with respect to shallow trench isolation, it will be having a high component density, whereas in the case of junction isolation, it will be having a low component density. So for sixth question, option 2 is going to follow. Seventh question, what they have given is, what is the gradient of a scalar field? That's it. So grad u or del u, what you're going to get means it is dou divided by dou x times of u into ax vector plus dou divided by dou y into u times of ay vector plus dou divided by dou z times of u into az vector. So here dou is the partial differentiation. So it is dou divided by dou x. You are going to differentiate the quantity with respect to x. So x square y you are going to take it as common. So it is 2x y plus x you are differentiating. So what is the parameter you are going to get? yz. So 2xy plus yz times of ax vector plus. If you try to differentiate with respect to y, what is the thing you are going to get? X square plus xz times of ay vector plus. With respect to z, first quantity will be equals to 0. Next quantity will be xy into az vector into az vector. Now look at the things. In this first quantity, I am going to take it as y as common, 2x plus z into ax vector or ax cap plus x, if I am taking common, that will be x plus z into ay plus xy times of az. xy times of az. So for this seventh question, which option is going to follow? Option number 1 is going to follow. In the eighth question, it is bit tricky question. What they have specified is f of a, b, c, d equals to some expression they have given, whether it is going to have 8 or if it is going to make use of only 8 cross 1 multiplexer with or without NOT gate they are asking. So for the first one, for the first option, if you try to solve, f of a, b, c, d equals to, how I can write 1, 3, 4, all those things. 1, how can I write? It is 0, 0, 0, 1. So it is a bar, b bar, c bar, d. And for 3 it will be 0, 0, 1, 1. 0, 0, 1, 1. And for d it will be 0, 1, 0, 0. 0, 1, 0, 0. And for 11 it will be 1, 0, 1, 1. 1, 0, 1, 1. And for 12 it will be 1, 1, 0, 0. And for 13 will be 1, 1, 0, 1. And for 14 it is 1, 1, 1, 0. And for 15 it is A, B, C, D. Nothing but 1, 1, 1, 1. Now look at the things. 8 cross 1 multiplexer means what? It is going to have 3 select lines. So I'll be making use of A, B, C as select lines. Here D is a variable 1. D is flickering from D bar to D. So it is in need of 8 cross 1 multiplexer plus 1 NOT gate required. NOT gate required. Let us try to solve fourth option. So 1, 3, 5, 7, all those things are there. 1, how can I write? correct? 0 0 0 1, and 3 it is 0 0 1 1, 5 it is 0 1 0 1, and for 7 it is 0 1 1 1, and for 9 it is 1 0 0 1, and for 11 it will be 1 0 1 1, and for 13 it will be 1 1 0 1, and for 15 it will be 1 1 1 1. Now look at the things. What is the nature of multiplexer you are in need? Just 8 cross 1 multiplexer is enough, because D is not at all fluctuating, so no need of a NOT gate. No need of NOT gate. So for A it is in need of a NOT gate, and for fourth one it don't require any NOT gate. So for A it is 4, and for D it is 1. Now look at the things. Similarly, let us try to solve for second option and third option. In the second option, what they have given is 1 2 6 7. Here there are only three literals. So 1, how can I write? 0 0 1. 2, how can I write? 0 1 0. Here it is fluctuating, right? C is flickering. 6, how can I write? 1 1 0. 7 1 1 1, right? So it is in need of 4 cross 1 multiplexer plus a NOT gate. Plus a NOT gate. What about third one? 1 3 5 7. 1 it is A bar B bar C. 3 it is A bar B C. 5 it is 1 0 1. 7 it is 1 1 1. So it is in need of 4 cross 1 multiplexer. So for 2 you are in need of 1 NOT gate. For 3 you don't require any NOT gate. So based on this, if I am trying to solve, which option is correct one? The suitable option for 8th question, it will be 2. Let us try to write the band gap structure. In the case of N-type semiconductor, you will be having the conduction band over here, and you will be having the valence band over here. Your intrinsic layer will be in the middle of conduction band and valence band. In the case of N-type semiconductor, your Fermi level will be close to the conduction band but below to the conduction band. So it will be near or below the conduction band. Near or below the conduction band. Whereas in the case of P-type semiconductor, what is the nature you are going to have? So this will be the intrinsic layer. Now where you will be getting the Fermi level? Fermi level will be close to the valence band and above the valence band. So P-type semiconductor, it is near or above the valence band, right? So for A it will be 3 and for B it will be 4. Corresponding option that's going to follow is option 4 is correct. In the case of intrinsic semiconductor, where will be your Fermi level? Where will be your Fermi level? Important. In the case of intrinsic semiconductor or pure form of semiconductor, your Fermi level will be exactly on the intrinsic layer. Nothing but those two energy states will be the same. And in the case of degenerate semiconductor, in the case of N-type, look at the things. The Fermi level will be crossing the conduction band, and in the case of P-type, the Fermi level will be crossing the valence band. Nothing but in the case of degenerate semiconductor, it will be above the conduction band. It will be above the conduction band or below the valence band. So for this 9th question, the corresponding option that is going to follow is option 4 is correct. 10th question is from transducers, electrical transducer. What they have specified is Hayes bridge is a modification of Maxwell's bridge. Yes, Hayes bridge is a modification of Maxwell's bridge is correct. The Hayes bridge is suitable for the measurement of high quality coils. Yes, Hayes bridge. Now look at the things. In the case of Hayes bridge, it is for high quality coil, and in the case of Maxwell's inductance capacitance bridge, it is for medium quality coil, and in the case of Owen's bridge and in the case of Anderson bridge, the quality of the coil will be low. In both the cases it will be low. Please try to remember these things. A Wayne's bridge cannot be used for the measurement of capacitance. Yes, it is not in a position to measure the capacitance because you are going to make use of a galvanometer. In the case of Owen's bridge, the balance equation are quite simple and must have frequency component. Even this statement is also wrong. So A and B is correct. Nothing but which option by default it will be followed means option 2 only. Owen's bridge can be used over a wide range of measurements of inductance. So we know that Owen's bridge is used for low inductance measurements. So nothing but it will be having a short range. But the statement E, what they are telling is wide range they are telling, right? This is a contradictory one. Since A and B are correct, by default we have to go for A, B, E. Nothing but option 2 only we have to select. 11th question what they have given is, in general, what is the value of Z input? What is the value of Z input in like in various cases? When you are taking ZL equals to 0, ZL equals to infinity, ZL equals to Z0, like this they are asking. The value of Zin which will be equals to this one, Z0 into ZL plus J times of Z0 into tan beta L divided by Z0 plus JZL times of tan beta L. Beta equals to 2 pi by lambda. This is very important, right? So for A what you are going to get is 4. For A what you are going to get is 4. Now look at the things. When ZL equals to Z0, remember these things. What is the value of Z input you are going to get? Z0. What is the value of Z input you are going to get? Z0. Got the answer, that's it. Now when ZL equals to 0, what is the value of Zin means it is J times of Z0 into tan beta L. Tan beta L. Similarly when ZL equals to infinity, it will be cot beta L minus J times of Z0 into cot beta L. Very important. So based on this, if I am solving for 11th question, option 1 is going to follow. And for the 12th question what they have given is, on the list 1 they have given BJT, MOSFET, IGBT and Diac. On the list 2 what they are telling is the functionalities they are speaking, that's it. We know that the BJT is a current control device and the MOSFET is a voltage control device. That's it. So for A what you should have means 4 and for B what you should get means it should be 3. So based on this, if I am solving, option 1 is going to follow. Very easy. And in the case of IGBT is a combination of BJT plus MOSFET. Important. So IGBT is a combination of BJT plus MOSFET. IGBT, what they are telling is, it is a power switching device with the fast acting features and high power capability with voltage control features. Important. And in the case of Diac, the Diac is similar to Triac, but you will not be having the gate pulses. You will not be having the gate pulses. But Diac is a bidirectional device. So what they are telling is a Diac is a 5-layer and a 4-junction device. True. 5-layer and 4-junction device. True. So for the 12th question, the corresponding option that's going to follow is option 1 is correct. In 13th question, what they specified is 3-phase power is measured by 2 wattmeter method and the readings of both wattmeters are equal. Nothing but W1 is equals to W2. Nothing but in terms of magnitude they are speaking. What is the condition of the power factor they are telling? See, W1, W2, in which cases it is same. So it is the same for which case? Phi equals to 0 and power factor which is equals to cos phi which is equals to 1. So it is in the case of unity. So for the 13th question, option 1 is going to follow. In the 14th question, what they have specified is a 2 kilowatt carrier is to be modulated to a 90% level. Nothing but what is the value of mu? They have given 0.9. What is the total transmitted power? They are asking. We know that the total power is given by PT, which is equals to PC into 1 plus mu square divided by 2, where mu is the modulation index what we will be getting. So which will be equals to 2K into 1 plus 0.9 square whole divided by 2. What is 0.9 square? 0.81 whole divided by 2, nothing but 0.405 plus 1 if you are taking, it is 1.405 into 2 if you are taking, it will be 2.81 kilowatt you are going to get. 2.81 kilowatt you are going to get. Nothing but option 1 is going to follow for 14th question. In the case of 15th question, what they have given is, again this question is from power electronics. Which of the following statement is not related to Triac? Not related to Triac. In the first statement, what they have given is, it can conduct in both the direction. Yes, it can conduct in both the direction, but in the question what they are telling is not related to. So first option you can eliminate. And in the second option, what they have given is extensively used for control of power in AC circuits. Yes, we are going to use, but not related to they are asking, so it is wrong. So it is a low power device. No, it is an high power device. In the fourth option, what they have given is, when in operation, the Triac is similar to two SCRs connected in anti-parallel. This statement is correct, but they are asking for incorrect one. So for the 15th one, option 3 is going to follow. And in the 16th question, what they have specified is, for a 4-bit binary serial input and serial output shift register, how many JK flip-flops are required? So it is how many in number? It is just 4 in number. It is just 4 in number. So for 16th question, option number 4 is going to follow. And in the case of 17th, what they are asking is to write the Boolean expression. That's it. This is the dead easiest question what they have asked. What is the value you are going to get? What is the expression you are going to get? So it is x bar, y bar, z. And here what is the value you are going to get? X bar, y, z. What is the value you are going to get? Y bar, z. So which option? First option is going to follow for 17th question. In the case of 18th question, list 1, they have given oscillator name, and in the list 2, what is the like a parameter they are asking. In the case of phase shift oscillator, what we know is you are going to make use of RC feedback, that to 3 pair in number. So for D it will be 2. You are going to get the answer. That's it. And in the case of phase lock loop, it is for frequency synthesis. And we know that in the case of crystal oscillator, it should be the most stable oscillator, because it is going to generate the clock pulses, right? And last but not the least, a frequency to voltage converter, it is for speed measurement. So for 18th question, option number 3 is going to follow. And for 19th question, VSWR can be easily deduced from Smith chart. Say true or false, that's it, right? So first option what they have given is VSWR can be easily deduced from Smith chart. Yes, VSW is nothing but the ratio of Vmax to Vmin, correct. And VSWR is the ratio of Imin to Imax they have specified, so it is wrong. The value of VSWR can be in between from 0 to 1 they have specified, it is wrong. Rho is varying from where to where? Rho is varying from 0 to infinity. What about the reflection coefficient? It is going to vary from -1 to +1. -1 to +1. Important. So based on this, if you are solving, so for 19th question, option 1 is going to follow. 20th question, what they specified is, in the case of RC phase shift oscillator, the impedance in the feedback circuit is a low pass RC network they have specified. right? So in the case of RC phase shift oscillator, the impedance in the feedback circuit is a low pass RC network. Okay. Then in the case of Colpitt's oscillator, the impedance in the feedback circuit is a low pass LC network. Okay. In the case of Hartley oscillator, the impedance in the feedback is an high pass LC network. D flip-flop is an example for monostable multivibrator. This statement is wrong. Quadrature oscillator generates 4 waveforms of different phases. It is wrong. It is wrong. So in the case of Colpitt's oscillator, the impedance in the feedback is a low pass LC network is true. And in the case of Hartley oscillator, the impedance in the feedback network is an high pass LC network. This is also true. So for 20th question, option 3 is going to follow. A statement. In RC phase shift oscillator, the impedance in the feedback circuit is a low pass RC they are specifying. Comment your answers in the comment section. In the case of 21st question, what they are asking is, they are asking for the incorrect ones. The ratio of Laplace transform of the output to the Laplace transform of input variable under the assumption that all initial conditions are set back to 0. This is the definition of LTI system. But since they are asking for the incorrect ones, first option is wrong. In the case of second option, what they have given is the ratio of Fourier transform of the output to Fourier transform of the input. This is actually wrong. Since they are asking for the wrong statement, second statement is the valid one. The third statement what they have given is the higher power of the complex variable S in the denominator is going to denote the order of the system. Yes, it is going to denote the order of the system, but they are asking for the incorrect ones. So third statement will be a wrong statement. In the case of fourth one, what they have specified is, it is the expression in the case of S domain relating the output and input of LTI system in terms of the system parameters and is independent of the input they have specified. Yes, it is independent of the input, but they are asking for the incorrect statements. So corresponding option that's going to follow for 21st question is second one. And in 22nd question, what they are given is, again match the following. What is the transformation equivalent they are specified? E power minus at into u of t, which will be equals to 1 divided by s plus a, we know. Whether it is real part of s is greater than a or it is less than minus a is very, very important, right? So it will be 1 divided by s plus a. Real part of s is greater than a. It is correct. So minus e power minus at into u of t, which will be equals to, again it will be 1 divided by s plus a. Only the ROC is going to vary. That's it. See, wherever you are going to have cos and wherever you are going to have sine, reverse it. Sine is there, right? So it will be for w divided by s square plus omega square. And in the case of cos of omega naught t, it will be s divided by s square plus omega naught square. That's it. Right? No need to have lots of confusions. So for 22nd question, which option is going to follow means second option is going to follow. 23rd question, again what they have specified is, arrange the following semiconductor devices in the decreasing order of operating frequencies or the speed they have specified. We know that the MOSFET will be operating at the higher speed. So MOSFET will be followed by IGBT, it is followed by power BJT, and it is followed by SCR. SCR is the slowest one. So when you try to arrange which option is going to follow means it is BACD. The corresponding option that's going to follow for 23rd question is option 4 is correct. And in the 24th question, what they have specified is, on the list 1 they have given the transistor ones, and on the list 2 they are asking with respect to the family. That's it. Emitter coupled transistor pair. Emitter coupled transistor pair, it is which one? ECL, emitter coupled logic. That's it. And in the case of multiple emitter BJT, it is with respect to TTL logic. And in the case of rail to rail output swing, it will be which one? CMOS logic. And the most efficient implementation of XOR function is achieved in the case of pass transistor logic, because here you are not going to take input as A bar B or AB bar. You are going to take the inputs as AB then A bar B bar. Nothing but since they are asking us to realize a XOR gate, we try to realize with the help of XNOR gate, because CMOS logic is going to give a complement ones. That's it. So for 24th question, which statement is correct? Statement 3 is going to follow. Nothing but option 3 is going to follow. Last question of this video. Till now, if you're not given a big thumbs up, please give it. In the 25th question, what they have specified is, let us compare delta modulation with PCM. What are the advantages of delta modulation over other modulations? They are asking. It is having lower sampling rate? No, it will be having the higher sampling rate. That is the advantage what we want, because we don't want any of the aliasing, and we don't want any of the overlapping, and we don't want any loss of the signal. Large bandwidth, yes, it is going to offer large bandwidth. And simpler hardware, yes, it is going to have simpler hardware. Complex hardware, it is not having. So delta modulation will be having the higher sampling rate, large bandwidth, and simpler hardware. So B, C, D statements are correct. Nothing but which option is going to follow? For 25th question, option number 2 is going to follow. So friends, in this part 1 video, we have covered from question number 1 to question number 25. In the next part of the video, we shall discuss from question number 26 to question number 50. If you have followed with the solution lecture, please give it a big thumbs up. Also share this video with your friends, and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Make use of the resources. Do well, study well. Thank you friends. All the best for exams.